All right, number 13, I think there was a typo, so we're going to change it to make this a 6. So we have x over x plus 6 equals a 3 over x. When you have a fraction equal a fraction, you can just solve by cross multiplying. So this gives us x squared equals 3 times x plus 6. So x squared equals 3x plus 18. So we want to make this 0, so we're going to move this over because we want to keep our x squared positive. And so this becomes x squared minus 3x minus 18 equals 0. So we get x minus 6, x plus 3 equals 0. So x is 6 and a negative 3. Go back and make sure 6 can be plugged in, which it can. Negative 3 can be plugged in. So x equals 6 and negative 3 is our solution. Alright, for this one, our parent function for this is f of x equals 1 over x, which looks like this. And you could graph that on your graphing calculator. And so now we want to use the transformations on this so that it looks like this. So here with this minus 5, that means it moves the graph 5 to the right, and that plus 3 is going to move it up 3. And the way you can look at that is because the vertical asymptote is when we this equals 0. So we're going to have a vertical asymptote at x equals 5. And we're going to have a horizontal asymptote at the y equals 3. So now if you were just to move that shape up and have this be the center, you're going to have something that looks like something like that, just a general shape. Now, you're probably going to use your graphing calculator, that's fine, but for me, I need to see the asymptotes written and drawn on the graph. Alright, one of the things you got to be careful with this graph is we have this negative, so it's going to invert our final graph. I'm not going to draw the parent function on this one. I'm going to just start with the vertical asymptote. Okay, so when this equals 0, that's going to be x equals a negative 2. So let's go ahead and draw that. And then we're going to have our horizontal asymptote at y equals negative 4. So if we were to draw it right now, it would be something like this. But because of the negative, it inverts the graph. So our final answer, so it gets flipped across, is going to be this. It gets flipped across the horizontal asymptote. So the orange graph is our correct answer. Again, I need to see the vertical asymptote, the horizontal asymptote. I don't need to see this black graph that we drew here. I just use that as a guide. Alright, so as we start 17, we are going to factor the bottom. And so we have x minus 3, x minus 2. And so you notice that the x minus 3 and the x minus 3 cancel. And so I'm left with 1 over x minus 2. And so when the x minus 3 and x minus 3 cancel, remember that's going to make a whole. And so the x value for that is going to be at 3. And so now to figure out where the actual whole is, you take the 3 and you plug it in. And so that would be 3 minus 2, which is just 1 over 1. So at 3, 1, there's going to be a whole. So at 3, 1, there will be a whole. Alright, so now if we look at the function here, the 1 over x minus 2, it's going to have a vertical asymptote when this is 0 on the bottom. So if we make this 0, x equals 2. So our vertical asymptote is at x equals 2. So go ahead and draw that in. The horizontal asymptote, I'm going to rewrite this over here so I can, so our function right now is 1 over x minus 2. And so our horizontal asymptote is the number after it, and so it's a 0. So our horizontal asymptote is y equals 0. So you can draw that in. And so this is kind of like the other graphs we were doing, just has a general shape like this. Not the best graph there, but and so the question is looking for an x-intercept, and since the horizontal asymptote is 0, it's never going to touch the x axis, so it's NA. The domain, so for the domain what we do is we look at a, see if I can, we look at this vertical line that goes across, it's touching, 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 so all these are good x values, but when it gets here on that vertical asymptote, it doesn't touch. And so that means that the domain is going to be all real numbers except, so all real numbers except x equals 2. And the end behavior, as this goes to infinity, so as x goes to positive infinity, y is going to 0. And then as x goes to negative infinity, y goes to 0 also.